Okay, so now we're doing conservation of energy, right? So we're comparing before to after, right? So we compress the spring, right? Here's this frictionless table, right? And we've got this spring and we compress it some distance, right? Okay, 5.8 centimeters horizontally, right? And it's 18 grams, right? So the X is 0.0580 meters, right? The mass of this marble, okay, is 0.0180 kilograms, right? So move that 1, 2, 3 places, right? And this is before. Afterwards is, of course, the marble speeding along, right? Oh, why is it doing that? It's smelling. Okay, anyway, the marble's speeding along, okay? And then the question is, why is it a massless spring? And the answer is that if the spring has mass at the moment of release, okay, at the point where it shoots this marble across, some of the kinetic energy is in the marble, but some of it's in the spring. And then, if you think about an expanding spring, this side would not be moving, this side would be moving as fast as the marble, and halfway down it'd be moving half as fast. And it's just a mess, So we ask these questions, we make the spring's mass negligible, right? And then we're okay. Now, the other thing that maybe you're missing here too is that this is a frictionless table, okay? So therefore the marble is actually not rolling across the table, okay? It's actually sliding across the table, strangely, without rolling. If it rolled, it would actually it would have a slower speed because it would have some, 1/2 mv squared energy, but it would also have rotational kinetic energy, okay? And so it actually would roll slower, and we'll learn, I think, in the 2 chapters from now how to solve the problem where this thing rolls. Okay, to solve the problem of a spring with mass, you need calculus, so we're not going to go there. But anyway, I hope I just confused you, didn't I? Anyway, basically what we're supposed to see here is that this is 1/2 kx squared, right? And it turns into 1/2 mv squared. Now I'll give you a clue on this thing, right? There's always the first question on the assessment's always the weird, change in energy thing. The second one's always a 1-to-1. Look for one thing turning into one thing. The third question is going to be a 2-to-1 or a 1-to-2, so 2 things turning to 1 or 1 thing turning to 2. And then the final one's always a 2-to-2. 2 things turning to 2 things. That helps. Okay, but this one's pretty easy. Let's just go 1/2 times 34. That's our k. All right, so we're saying 1/2 kx squared equals 1/2 mv squared. And then this is 0.0580 squared, and then that turns into 1/2 0.018 v squared. Okay. Now, probably if you're watching this video, you probably understood this long ago. You just don't understand how to turn centimeters into meters or grams into kilograms. So you hit stop in disgust a while ago, I imagine. Okay, so let's go 0.5 times 34 times 0.058 squared. Now I'm solving for v, right? So I'm going to go times 2 divided by 0.018. And now I've got, of course, what v squared is. Look at that, right? And I'm going to square root that. So raised to the 0.5, enter. I get 2.52 meters per second.